All right, IM2 classes. Today we are working on complex numbers. We've been talking about a little bit solving quadratic equations. I'd say, a quadratic equation, it might have no real solutions. So we're going to look at what those solutions would look like, those non-real solutions. They're called complex solutions or imaginary, is what they're commonly referred to as. First thing we need to talk about is the imaginary unit. I is the imaginary unit. So all it is the square root of -1. So when we're dealing with square roots and we try to take the square root of something like -9, we couldn't do that before because the square root of -9, there's no real solution to it. There's no real number that when you square it, you get 9. All right, so the square root, so there's no real solution for the square root of negative numbers. The imaginary unit solves that problem. So to solve that problem of square roots of negatives, when you take the square root of a negative, you say it's imaginary, you put an I on there. Problem is now solved. So let's look at some examples. It sounds like it can be confusing, but actually doing these is real simple. So when we're taking the square root of a negative, so say square root of -25, we know the square root of 25 is a positive 5. You just slap an I on there if it's negative. So it's -25, the square root, oh, you can't forget plus or minus 5i. That's it. All right. So if we have something that's not a perfect square, like 72, so what I'm going to do is a buddy system. I'm going to do a factor tree on 72. 72, that's 2 times 36. 36 is 2 times 18. 18 is 2 times 9. And then 9 is 3 times 3. Remember, simplifying radicals. I'm going to put all these numbers, 1, 2, 3 twos. 1, 2, 3 twos, and then 2 threes back underneath the radical. Then I search for pairs. Nope, wrong button. Search for pairs. We have a pair of 2s. So for every pair of 2, for every pair, 1 goes on the outside. Then I have a pair of 3s. For every pair, 1 of those goes on the outside. There's still a 2 left on the inside. So now I'm ready to simplify this. So 3 times 2 is 6. Since it's a negative, right? Since we have a negative 72, I'm going to throw an I on there. I'm going to put it outside the radical, and then that 2 is still left in. And don't forget, it's still plus or minus. So plus or minus 6i root 2. So that's all you got to do. When you have take the square root of a negative, take it, whatever the positive would be, and then slap an I on there to make it an imaginary number. And problem solved. We can take square roots of negatives now. It's now imaginary. Great. So here, -5, root 9, so it'll be -5 times. I'm just separating this out a little bit, rewriting it to make it a little bit more sense. And ignore this -5. That's annoying. All right. So square root of -9. So square root of 9 is 3. And since it's a negative, I slap an I on there. So -5 times 3 is -15i. There we go. All right, moving on. So there we get 242, 5 through 10, an assignment. So now we're going to talk about a complex numbers. So complex numbers, they have a real number part and imaginary number part, and then we add them together. So a complex number is some real number plus an imaginary number. If the real number is 0, it's just the imaginary part, that's still complex. Technically, a real number plus a 0. So like they're all complex, but what we're dealing with here is a real number part plus an imaginary part. Just to get used to seeing this, what we're going to do here, we're going to find the values of x and y that satisfy this equation. right? So all this is just matching up the real number parts with the imaginary parts. So I have 2x, here's the real number part, 10 is the real number part here. This negative 7 belongs to here. So all I need to do to solve these, I'm going to set the real number part equal to each other. Well, I need my pen. I'll do the real number part in, well, I'm not going to write in yellow. I'll do in blue. So the real number part 2x is equal to 10. So 2x and 10 are the real number parts, them equal to each other. Solve, you get x is equal to, what the heck am I doing? X divided by 2. The real number part is x is equal to 5. On the imaginary part, that one's a little bit simpler. So negative 7 is equal to y. And that is done. That line is super annoying. So you just need to set the real number part equal to each other and the imaginary part equal to each other, and then solve. This one doesn't require any solving. This one required a little bit. All right. So let's look at another example. So instead of highlighting, I'm going to box an appropriate color. So here's my real number part over here. So I'm going to set those equal to each other. So 9 is equal to negative 2x. Solve for x. I'm going to divide both sides by negative 2. That cancels out. Get 9 divided by negative 2. That's just negative 9 halves. I'm going to leave it like that. If it makes you feel better, you can do negative 4.5. Doesn't make me feel better, so I'm leaving it like that. This one will do in green. So here is the imaginary part attached to the I. So I'm going to set those parts equal to each other. 4y is equal to 3. Solve for y, I need to divide by 4. So that cancels out. I get y is equal to 3/4. That's it. So just set the imaginary part equal to each other, real part equal to each other. And all that is just identifying, helping us practice identifying the different parts. Last thing we're going to be doing is adding and subtracting complex numbers. Real simple. All it is combining like terms. We can hear, so we have 8 plus 5 is 13. And then this is a negative I plus 4i. So that's, remember, there's some invisible math that'd be like negative 1i. So negative 1 plus 4 is a positive 3i. That's it. Just find the like terms, add them together. Cool. Let's do subtraction a little bit here. We're subtracting complex numbers. What I'm going to do is distribute this negative in front. So that's going to be a negative 3. And then since this is a negative 6i or minus 6i, then the negative and negative make that a plus 6i. And then I bring down this stuff. And now I just combine like terms like the others. I'm going to color code this time. I like it better when I color code. I didn't like it the last time. So 7 minus 3 is a positive 4. And then next one, so I have a negative 6 plus 6. Oh, look at that. Negative 6 plus 6 is 0. So the answer is just 4. That's all we got to do. Next one, this one's a bit of a mess. There's a lot going on here, but we're just going to do the same thing we did in the last one. I'm going to distribute this negative. So that becomes a negative 2. Over here, that becomes plus, that's going to be a, let me fix that. So that's going to be a negative 7i after I distribute. Bring down the other parts to here. And look at that. It's all lined up. Oh, One of these days, I'm just going to start cussing at these videos because the stupid PowerPoint here keeps putting those extra lines. It's super annoying. But anyway, the like terms are right next to each other. I'll still color code them. So I have a 13 minus 2 is 11. And then the other set of like terms, the imaginary parts, I have a negative 7 plus 5i. That's going to be a negative 2i. So 11 minus 2i. If I write it all in black, maybe it looks nicer, but that is it. So that'll do it this time. Next time we'll be doing multiplying complex numbers. Fun times.